My name is Wayne Gibbons. I'm a lecturer in the Department of Building and Civil Engineering, and I'm the chair for this session. We have a number of very interesting speakers for you this morning. So I'm going to start off by introducing Mark Kelly. Dr. Mark Kelly is a lecturer and a senior researcher here at GMIT.
Thank you very much, Wayne. What I'm going to do today is I'm going to do the introductions. We have 4 speakers today, including myself, Paul Mannion, who's associate with Scott Allen Walker Architects. We've Brian Holmes for a project manager with Land Contractors, and we've Jan Gotcha, who's a current PhD candidate at the Department of Building and Civil. I suppose the idea of today is to link some of the research activities we've been doing over the last couple of years to an actual practical case study that's under construction at the moment. And just a little bit of background, through 2 different funded projects we were actually involved in the design stage with Paul at Scott Allen Walker's under EPA's Drive program funded project, and subsequently under Cleaner Greener, a production program project again funded by the EPA and supported by Kerry Developments and Land Contractors. We were on the construction phase of the HPB. So the idea of today is to show you hopefully the interrelationship between what we did during the design phase and how it carried through to the construction phase. So basically starting off, Paul is going to give an overview of the design issues of the human biology building. I'm going to step in then just to introduce the interventions, as we call them, from a waste reduction point of view. Then I'm going to hand over to Brian, who's going to talk about the construction challenges. And then we have Jan, who's going to look at the resource efficiency strategies that are currently being implemented on the job. And finally, I do a short conclusion on it. So first of all, I'd like to welcome Paul Mannion to talk about the design aspects.
Great stuff. Can you all hear me? Good. Well, I suppose, just make sure this is working. The other way?
Okay, that's good.
One more.
Yeah.
Okay. Thanks for that. So we panic over. The idea, I suppose, that comes to our mind immediately when we're engaged to develop a new design for a building project, and particularly a university building project, is that we tend to revisit in our heads the idea of a university and what is it that a third level institution or a university is about. And it's a good idea to do this so that we don't kind of rush into the next building project doing what we did before exactly. So it's worthwhile finding out what is our commissioning institution about and what are they doing and what are they doing today. In the case of the university, there are the 2 main, I suppose, pillars of what they do is about teaching the undergraduates and then doing their research and moving their research forward. In the case of the human biology building, the research is science-based and technical, and so it's going to require a brief full of technical spaces as well as offices as well as teaching spaces. And so this picture I put up here of the NUI Galway campus also reminds us that the university is about anything as well as teaching and research. It's also about the environment in which that activity takes place. And I'm going to come back to that hopefully just at the end of a couple of slides I have here. Of course, the reality is when you get into the grain of our universities in Ireland is you find that while there are landmark buildings and there are award-winning designs, an awful lot of teaching and research, and probably in this institution as well, takes place in repurposed buildings, temporary buildings, buildings that have been bought and are due to be redeveloped. And this is the case on the site here. It turned out that our user group, the medical faculty in the medical school, were not the occupants of the site themselves, but other sciences had begun to occupy the former part of the former IMI factory and IMI complex that had been bought by the university about 20 years earlier. In this case, there's a commercial type building with an office block in the front of it and a large shed at the back, which you can see from the photograph, extended and adapted very cheaply a number of times. And so we were involved in the design of some of the laboratories that were fitted out in a very low-tech fashion, that have been working away for about 20 years. So one of the difficulties then about developing the kind of core sites or brownfield sites in the middle of the university is that they'll generally be occupied by something else already, and they have to be decanted and moved out of the way. So that was probably the first challenge, was to remove very valuable funded research activity from a very poor building and find somewhere else for them to work. So this is constantly a challenge in these kinds of projects. I suppose the other thing then is, as part of the environment, you find that sites like this on the periphery of a campus or that have been acquired by a university will have probably been neglected from a landscaping point of view. So you have all kinds of existing finishes, buildings that are remnants from earlier buildings. In this case, there was some historic buildings on the site that were some outbuildings left behind, some self-seeding trees, and the Newcastle River there behind those trees on the left of that picture. Hidden features on the site that wouldn't always be obvious to even students walking past. What this photograph shows us as well is there's a concrete avenue there that's was one of the most well-travelled routes through the campus by students moving between the Art Science Building and the student bar probably. And we'll show you that on the aerial photograph. And then other existing buildings on the site would have things to be dealt with like asbestos panels, timber to be recycled, the masonry itself, and maybe, I'm not sure Mark might refer back to this, some of the work that was done in our office with the GMIT would have been to do pre-demolition audits of these buildings and make arrangements for recycling and reuse of some of those elements of the building. In this case, we also had these untended trees that were growing on the site, most of which form a very pleasant backdrop to the existing buildings, but most of which were not that valuable and required to be taken down for safety reasons and also because they would be in the way of the development itself. So some hard enough decisions just to establish the site in the first place. Now, one of the things that happened when Mark sent me the template for today's slideshow was I got a blank slide like this with a template on it. And I struggled a bit to fit some of the images that you're seeing on the slide. And so Mark has forgiven me for turning off some of the graphics on the later slides that you might see. And I put this up here to remind myself of one of the other things that a design team, an architect-led design team will often do. And it's possibly the most significant moment in a project when you have the opportunity to determine exactly how sustainable the whole of the rest of everything else that you might do will be, where you sit down and look at the brief. We started on a new project recently where we thought, we would take the client's brief as it was issued at tender stage and work away in the background and table something for discussion. And they said, well, that's fine, but that brief was only for funding purposes, so it wasn't a real brief. So you do have to be careful and challenge, is this what you really want, this list of stuff? What are you hoping to achieve? And try and understand what their teaching objectives are, what their overall numbers are, and what their research objectives and likely future funding will be. In this case, the building was designed with something like 60% room for expansion in the research area, and they had a very accurate idea of where their next 5 years worth of funding for new projects was coming from, for example. That meant that they already knew that their existing facilities were going to be overwhelmed if they were successful in developing their new research areas. And so that's the first task, I suppose, is to challenge that brief and to look particularly at synergies that you might find in the emerging brief so that you could, for instance, reduce the floor area or even challenge whether some existing facility might be retained and not built as new, or omit altogether some aspect of the building. If, when you challenge the users to work together, sometimes you find that they haven't really spoken to each other. In the case of the human biology building, there are 3 departments, anatomy, physiology, and pharmacology, and they did have a certain amount of overlap when it came to things like their office space and their teaching rooms for the undergraduate teaching. And so, whereas at the funding stage they would have each developed a separate brief, What was required though was a single building, and they were able to sit down and work together on some common aspects of what they wanted to achieve, and thereby we can reduce the footprint of the building maybe by 600 or 800 square meters. And that change in itself could well be the most significant and sustainable thing that you do. First of all, decide, do we really want the building? Decide on the most appropriate site, and then how big is it going to be? And that site was put there just to remind me to say those things. In our case, we did an interesting thing with the user group, which was partly at their own suggestion, which worked very well because we've lots of experience in designing third-level buildings where you have multiple users or multiple departments involved, and we find that each department digs trenches for themselves and they snipe at the others and they try and defend their rooms and their spaces. In this case, what we ended up doing was we formed a committee or a user group for each of the aspects of the building. So we had a research group, a teaching group, a group who looked after the offices and the office space, and a group who looked after the briefing of specialist rooms like microscopy and animal research, for example. So we had 3 or 4 interest groups formed, each group having members from all 3 departments who were concerned with the building. And that led to a lot more synergy and a lot more of people sharing facilities and understanding what the other people were trying to do. And this would have affected things all the way down to the amount of IT in the building, to the use of gases, to the way that waste was managed and how many waste storage rooms we would have required in the building. So it's almost impossible to say, but quite a significant effect was had on the floor area and the design of the building as a result of that. So it's useful then to have some kind of a vision coming out of the briefing process and going away with the team and together with the engineers and looking at the site constraints and trying to pull together something that will also represent the university for the whole generation of students to come. And to get there, though, from the brief to this is the design task. The other thing that goes on in architects' heads, looking at these kind of things, will be the environment we work in. And in the case of all of us on this island, we're working in an almost entirely man-made landscape. I put up this slide to remind us of this because at first it's not obvious that almost the whole landscape of Ireland, maybe bar some cliffs in Donegal and the cliffs of Moher and some coastal areas, is in one way or another looks the way it does because of the intervention of humans and farmers and builders. And we have done this, and you can see in the landscape around Galway, mountainscapes that have been denuded of trees, lake levels that have been created by drainage schemes, castles and ruins of monasteries from former upheavals at different times in history. And they all form a kind of a backdrop that we're so used to that we don't even see it anymore. And so we have, against this, a huge responsibility to develop and use those resources in that landscape in a sustainable fashion. So it's easier to see when you come into a more urban landscape that is obviously a man-made artifact. In the case of the university, the site is divided by the Quincentenary Bridge shown on the top right of the slide here, where while the campus did develop something like 260 acres of available land, the original 36 odd acres south of the bridge are stuffed with the most significant buildings in the campus. And a decision has been made in our master planning to intensively develop this southern site before moving on, as they have done since this building started being designed, with the development of the northern campus. So in our case, it made sense for us to look at maybe inserting the building and demolishing some existing buildings in order to have this medical school in the correct place on the campus. And so in the middle of all of that, we have the initial discussion, I suppose, about how big is this site. At first glance, it didn't look particularly big in the first slide, maybe, but you see this here during an enabling works contract that Coffees undertook, where the site was cleared, with the exception of a few trees. The site was cleared and existing buildings partly recycled, and this is the debris that's left behind. Suddenly, by contrast to the earlier photographs where everything is enclosed by buildings, outbuildings and overgrown trees, you're beginning to see more of the light here, and that there is in fact a very significant site to be found. Part of this site selection process is informed by the, I suppose, development of the campus itself, where there is a slide of the university site hatched in grey prior to its expansion. So that was probably a situation only in the 1960s, the end of the 50s, say, that sort of site would have been in place. And you can see the words IMI written on the building on the top right there. And that whole area of the site was an industrial complex that eventually was acquired by the university, along with all of the land up along the river on that side. It always strikes me that these people who made these decisions were dealing with a campus of 4,000 or 5,000 students heading for maybe 6,000 or 7,000. I think the Scott Walker Master Plan of 1974 maybe ring-fenced itself at something like 10,000 students. We all know that it's well beyond that now. And this campus probably has experienced similar challenges in planning. But what strikes me about it is the foresight that those people had to buy a ridiculous number of acres of land to set them aside. Surely most of the North Campus of the university would have been developed, you know, for housing in the meantime and by private developers if this hadn't been done. And we're already reaching a point when you look at the Campus of the Future plan. This is from 2010, I think, where the building projects that were being either on site or envisaged at that stage, highlighted in blue there, looked like the last possible major developments in the southern campus. You can see on that slide that there are two possible locations still being considered for the human biology building. One on the site of the existing anatomy department, which is the one on the left there near Newcastle Road, and the other one is identified as the site of the event. So that I don't use up too much time, I'll talk a bit about building design. I don't know if the pointer has a headline on it or not. Yeah. So we have the Art Science Building here and the James Hardiman Library being the complex of buildings from the 1970s, and then the IMI site being this whole area here to the south of it, bounded by the Eglinton Canal. And running through all of this is quite a small stream or canal, which is actually Newcastle River, and to some extent it's a victim of being dumped on by surface water from throughout the campus, so it's not always the most pleasant river. But there is an engineering solution further north that's being developed at the moment to keep that flushed with fresh water from the corridor. So our site then ends up being this portion of the IMI site adjacent to the southern end of the Art Science Building. The concourse that you might all know that runs north-south along this building here, and underneath it the service road is on that line. And so that's one of the kind of desire lines on the site we have, is to keep people moving alongside the river here. The existing buildings below this are the Bailey Allen Hall and the student bar and theatre, as well as an administrative building at RC College. So there's a lot of student activity in these buildings and a lot of academic activity up here with a common area running north-south. So we wanted to extend that in some way within the building or within the envelope of the building. I won't leave this up for very long. This was the guts of our brief. You can see that there were different categories of space dominated by teaching space, but then a large amount of research and office space as well as some special areas. So to fit all of that in a site which was about a quarter of the size of the brief, we started looking at developing a building that also took account of the changing geometry between the angle of the Art Science Building and the fact that the IMI was on a slightly different setout. So whatever building we were going to design was always going to have a splay of either within an atrium or in some way within the design. We'll see how we eventually resolve that. This was an early attempt at accommodating the brief on the site. We would have started working in 3 dimensions very early on with simple SketchUp models because it's a very quick way of working and enables you to demonstrate very quickly to the client what's happening. We also began to develop a kind of a 3D vision for the building as well, and how it might look with the river in the foreground and the sun shading Greece Soleil on the western elevation. So this is what we developed into a plan that's a wedge shape with kind of 6 metre grid in both directions. Brian from the contractors will tell you how difficult it is to build with every single one of these changing shapes slightly as you move. Every single one of these modules is a slightly different shape to the rest. So a big challenge, and probably something I won't do on that scale again because it's really, really difficult. But essentially what we've done is we've picked up on that north-south route on the side of the building, and we have created an atrium within the building with a very large teaching space in the front of it. On either side then there are administrative offices, generally speaking, and at the back of the building stacks of research and teaching laboratories. So the idea here is that we've recreated a plaza or urban space between the front of the building now on the south side and the bar and theatre building here. And in extending that public space in through the atrium and out again, we've made the building part of that whole establishment down here. Also then the ground floor of the building will be accessible to students who might be using a timetable theatre here and timetable seminar rooms that will not be the exclusive use of the people in the building. And so we have managed to create an undergraduate teaching laboratory space, undergraduate teaching spaces and some offices and support on the ground floor. And then on the first floor, develop that still further, where we have a walk-up staircase to the first floor for more of the undergraduate teaching areas in anatomy. By retaining a kind of laboratory zone on the north side here, we've given them north-facing windows and also a series of service stacks, both in the depth of the plan and at the gable ends, here and here, which kind of put manners on how you might service the building. And then maybe in section this explains it better, where the public space between the bar and theatre is here. It's a slightly raised ground floor, brings you into the three-story or four-story atrium here, and the specialist rooms for microscopy and the research in the basement. The development of the site at this location justified the expense of excavating a very large amount of very hard rock out of the site and doing all of the demolition, because it puts the medical training building in the heart of the campus, close to existing other medical research and the hospital itself, whereas the alternative might have involved developing a site on the North Campus. So that means that both students and academic staff can walk between the various facilities or use the campus bus, but don't have to be driving. The other plans then are similar in shape. As you walk through the building, you find that there's a very large atrium with offices and write-up areas for the research, as well as the research laboratories themselves. These plans are a bit old, but I've used them because they're very simple to explain. Again, the suite of research offices on the top floor and its write-up areas. One of the things we encounter constantly with science buildings is the difference of attitude that come from different science cultures regarding this business of how you do your write-up, how you do your research. Some American researchers tend to prefer to do their write-up in the lab, and that's the way they've been brought up, if you like. In European institutions, they tend to like to remove the write-up to somewhere else. In this building, we have provided separate write-up spaces, both because that's the likely culture here, but also because there are phases in development of medical research that mean there might be several years of writing up and only a few months of laboratory. And that would mean that the team then can continue to work in here, and another team can use the lab space. So it's a bit more sophisticated than having to write up beside your desk, which might seem in the commercial world to make sense so that people aren't walking around. But in the kind of academic environment and the models of funding they have here, there's quite a large amount of write-up space in various parts of the building relative to the amount of lab space, and we'll see how that works out over time. I'm nearly there, guys. We'll talk about the roof. Within the building, we just put one floor of staircase in the atrium, which encourages the undergraduates not to be using this. Undergraduate teaching for medical, the medical department happens on those 2 floors, and the research on the 2 floors above. So it gives kind of public ownership of the 2 undergraduate floors. And then I have a couple of slides of the finished design. Long journey to get to this particular design. We've used 2 materials just on the elevation, so it's about 3 if you include the glass. So it's glass and metal, aluminium, and then stone clad gables, which is an unusual use of that quantity of stone, and we hope it will have the right kind of impact. Along the walkway, we've developed a grisaille that would have been on the west face of the building by removing it slightly off the building on a series of 5 or 6 slender columns, and we've put some roof lights just on the top of it, which are all very functional and maintain light without having the solar gain effect of the low sun. We also went to a lot of trouble with the stacking of the services and the determining of service routes to make sure that everything is contained in our stainless steel clad service towers here on the 2-story platform on the roof. And that's what it should look like again on the side. Finally, just to remind everyone, what I started out saying was this task of how to embody the idea of university and the university building in a new building or a new part of the campus. We would argue always with 3rd level colleges particularly that they have their twin pillars of teaching and research, and possibly a 3rd one, which shouldn't really be estate management or facilities management task, which might result in, acres of temporary buildings or rented spaces, but involve a much larger responsibility of stewardship and stewardship of our heritage and stewardship of proper buildings that will last the test of time. So thank you.
Thanks very much, Paul. I'll be quite quick. Basically, in 2008, we got funding from the EPA, as I've already mentioned, which the aim of the funding was to work with design teams to see if we could prevent or design out waste. Now, unfortunately, that's when the economic crash happened. It was quite difficult to get in a lot of design teams, so we're very lucky that Paul and Scott Tanner Walkers let us have access to their office for about 18 months, I think the basement was. And they were working at the time on the design of the human biology building. So our aim was to see how could we integrate waste reduction measures during the actual design. So what we did, we came up with a list of sort of recommendations. As Paul mentioned already, first thing to do was to carry out an external visual pre-demolition audit, which we produced a report for that, to identify any materials that could be reused, recycled, or could the parts of the building be deconstructed, or were there hazardous materials with wires and asbestos panels there, things like that, that would need a specialist to remove it. Then we decided to set some targets for the project, and it'd be quite unusual to have these in the design brief or the design phase. 90% diversion from landfill. And then we decided to go quite specific to looking at the demolition phase or the enabling works, and also the construction phase, so the targets are set out there. And we also used BREEAM as a guideline for actually identifying the meters cubed per meter squared or tonnage target. So what we found, these found themselves being in the architectural specification and the design brief, and they went to follow through then to the main contractor when they won the bid, and then as part of their site waste management plan, they had to go about trying to achieve these targets. Also, we prepared a template for the design phase, construction, demolition, waste management plan, and highlighted issues again like supplier take-back schemes, subcontractor management, and so on. And the idea there was not to say, well, to the main contractor, go ahead and solve all these issues. What we wanted to have is to already have a document that we could hand to a main contractor and to say, and subcontractors, and say, well, here's what we're thinking about doing, and have a discussion about that. Some other issues that ended up in the architectural spec through Scott Tanner Walker's open sort of initiatives as well, and things that we recommended was having recycled content percentages, some off-site construction elements, reduction in the basement depth, and deconstruction of some elements as well. So they are also contained in the architectural specification. It was interesting for us to sort of get beyond maybe the stereotypes of sort of architectural profession, and to say for every recommendation we would have Paul and his team in the Galway office, they would give us a list of reasons why that may or may not work. So there was quite a lot of depth to their thinking. It's not that they just ignored waste. We were focusing on one thing, but they had a whole host of other design strategies and issues to think about. So we incorporated as much as we could. And the result of this part of the project, Jan is going to present another part in a few minutes, is that you might see them outside there are the EPA fact sheets and tools. Basically, we decided to develop an agreement with Scott Tanner Walkers, and also we did the construction phase of the Martha Hospital with John Sisk in Dublin as well. We took those two case studies and decided to develop a sort of toolkit for best practice, looking at different principles and strategies of preventing and designing our waste. So those are free to take, they're outside on various issues. There's also a report to go with that on the EPA website as well. So that was the design phase interventions. What I'd like to do now is introduce Brian Holmes, project manager with BAM Contractors, to talk about some of the construction challenges that they currently face.
All right, I'm Brian Holmes, project manager with BAM. I suppose we tendered the HBB project. I'll call it, it's human biology building, but a HBB project. We tendered it in 2014, and we started on site first thing back in January in 2015. But just, I suppose, the project was initially designed back in 2008. I suppose certain reasons may mean it have been shelved for a number of years. I suppose economic being one. But I suppose that was one of the challenges. A building designed back in 2008, obviously certain regulations and certain items change from over a period of time, and I suppose we had to work with Paul and work with the design team to develop the design to ensure it complies with the current standards that we have to work to today. I suppose one big challenge with the project is it's a centre of campus project from a construction point of view. I have a small little brief animation video that I'll show to you there. It's about 2 or 3 minutes long. I suppose it'll give you an idea of the phased and how the building was constructed. Just to note on it, some of the timelines, because it was tendered back in 14 and we didn't start until 15. The timelines, I suppose, just don't heed the timelines, but just you can have a quick look at that. That's the site there. Obviously the enabling works was done before we started on site. you note there we have a bit of enabling works to allow the realignment of the road to give us the full footprint of the building, just to keep that in mind. I suppose just to note that this is probably where the current stage is where we are at the moment on site. Okay, so I suppose that gives you a quick introduction to the sequence of how we felt we were going to construct it, and how in fact it turned out that we did construct it. And I suppose 3D models give us a good idea and a good perspective on how things are going to function and how they'll operate on site. I suppose just a quick project overview. Paul said there that the enabling works have been completed. I suppose this was a huge advantage because obviously the enabling works involved a huge amount of rock breaking. I think the enabling works tender went out to take advantage of the summer period in the college. Obviously, it's a huge noise, huge invasive works. So I suppose the local residents and the college, it was least disruptive. So that was completed before we arrived on site. I suppose one thing we noticed when we were initially tendering the job was the basement. It was a hole in the ground and it was left that way for approximately a year before we started on site, but that the water table level was quite high in it, and this was clearly evident by going into site. I think we calculated the water table level was at about 1.5 metres above finished floor level. So I suppose we had to take recognition of this when we were tendering the job, because obviously the basement had to be waterproofed, and I suppose I'll touch on that a bit after. There's 4 floors above ground, mixed use, and a plant room on top of that again. There's a circulation and atrium area, there's teaching areas, there's laboratory areas, and there's office areas. So it's a high, Paul has gone through it already, but a high mixed use building. The basement is a testing facility. I suppose just before I go on to that, I suppose just we have to take account that obviously the basement is a testing facility, and I suppose we'll touch on this just a small bit after, but we have to take recognition of workmanship around the basement. Project constraints that we encountered, I suppose we all talked about the canal. There's an existing canal there, and it's classified under an EU directive as a special area conservation. And that is because it is a tributary of the River Corrib, and that's why it got its classification. So I suppose when we arrived on site, the basement was 1.5 metres above finished floor level, probably about 2 metres of water covering the whole footprint of the site. We had a huge amount of water there, firstly, that we had to discharge off site before we could even start our works. We can't just pump it into the canal. Canal is deemed a special area conservation. So I suppose we engaged with all the regulatory authorities, and we engaged with them closely and came up with the solution that we would actually discharge the surface water into Fowl, and we agreed this with the local authority. And I suppose this mitigated against the risk of us polluting the canal and potentially polluting the River Corrib. And the second obstacle we came across there was actually an invasive weed on the site called Japanese knotweed, and I suppose it's becoming more relevant in more recent years. You'll see it along water courses, you'll see it along roadways, and you have to receive a licence from the Department of Arts, Culture and the Gaeltacht to remove it. And I suppose that was one challenge, and it has structural implications in porous concrete. The roots grow into the concrete, they expand, and they can actually in fact crack concrete. So that's something we had to get a licence from the Department of Arts, Culture and the Gaeltacht, which to remove it and get a licence and a certificate of clearance. Similar procedures in place to remove asbestos, in fact. So there were 2 constraints that we met, and another one was obviously the big elephant in the room. We're large, where the site is based here, and Paul talked about it here. This is the main thoroughfare. The hoarding was set up when we arrived on site because the enabling works were complete. But this is the main thoroughfare for the college. It actually used to pass through here, but this was hoarded off. So the natural route for pedestrians was that they were coming around here, coming down here, and going to the college bar on that side, and that we had a natural boundary of an SAC canal on this side. So I suppose this influenced some of our choices of products and some of the decisions we made on the project. I suppose there's a huge risk there, and when we were tendering the project, we had to take account of that. The amount of deliveries we bring to site, the amount of disruption that we can bring to the campus without affecting the campus and the way the campus operates. So that, I suppose they're two of the constraints. When I move on, I suppose you'll see why we moved and made some of the decisions we made. I suppose in our design development, and the design didn't limit it to in situ concrete, but we had a previous experience of using precast concrete, and I suppose we found this a huge advantage. One, going back to the fact that we were in a live university campus. If we were pouring in situ concrete, we had large amounts of concrete deliveries, pumps to be set up on a confined site. We had the room to do this, and I suppose a cleaner environment, cleaner site when we're using precast, and taking into account that we're beside a canal that's a special area conservation, and the implication of polluting that if it did happen. So I suppose we went ahead with precast, and I suppose the advantages to us on this job with precast was we had a reduced number of deliveries. Orden Precast was the precast manufacturer for this project. They take the initial design, they develop the design, and they come up with the proposal. We propose this to our design team, our ER, and the technical advisor team for the job. I suppose the advantages for all was reduced deliveries. We had an enhanced finish, a factory controlled finish on the precast. We had improved program implications. You might have seen on the animation there, we were shown finishing in July, we'll probably run into August. But with in situ, we're saving about 3 to 4 months with the use of precast. I think roughly on site we were achieving a floor every 2 weeks. We wouldn't achieve that with in situ concrete. We had reduced waste, which was a huge thing from concrete wastage. We had obviously one thing we've encountered is that using in situ concrete, there's a huge amount of waste. We had an improved environmental statistics, because we could get the statistics from more precast and the reduced waste, and we had an improved finish. Disadvantage, I suppose, with using precast is it's an increased cost, and we pay a premium for that, but we feel to think that it reduces our prelim, so potentially it might work out cost neutral at the end of the day. And a disadvantage, although it be a disadvantage or an advantage, we had to have the early coordination of services because we had to ensure that our oaks were in the right location. Second thing there was, obviously we talked about the basement and the importance of the basement and the laboratory and the testing that involved in the basement. We went away from the standard pre-proofing, and we had used this product. It's called a Roscar. It's an injectable water bar system, and we found it a success in previous projects. And I've worked with it myself on previous projects. I suppose the advantage of using this system was it was insurance backed and an insurance backed warranty. So if the basement leaks, doesn't matter what caused it. It won't say it was done by one and it was done by the other, because it's insurance backed. Roscar, backed by Zurich Insurance, will fix the error or the problem or the leak no matter who caused it. And this is insurance backed for 15 years. So the college has a huge advantage in using this system. There's a reduced risk, as I talked. Quality control, Roscar are on site to install this system and install the injectable, and they monitor that. Increased productivity because of the restrictions on pours. Using Roscar system, you can pour the whole basement slab in one pour if you want it, because they use a system of crack inducers. The disadvantage is increased cost, and secondly, if you have a design team that hasn't used it previously, getting the design team's buy-in. I'll finish up on this, but just so you know the system, you'll see there, you pour the basement slab, you put in this channel before you place your wall. That is then injected once the concrete reaches its 28-day or full structural strength. To increase the size of the pores, we use what's called a crack inducer. When all the concrete has gone off, you'll see these yellow, it's a spongy type material. The company come and inject it. And to be honest, in my experience, I've done a swimming pool with it. It's passed the drop test first time, so it has a 100% success rate with myself, and hopefully on this job it'll have a 100% success rate also. So I think that's me. Right.
is Jan Gutcha, and the part of my presentation today is on the implementation of resource efficiency strategies on the human biology building. So what is resource efficiency? Well, resource efficiency in its most basic form means doing more with less, and it covers the areas of energy reduction, waste management, water usage reduction, and as a result of that, it also reduces your carbon emissions. So why do we want to improve resource efficiency? Well, the EU states that it can increase economic opportunities, lower costs for the building contractor, improve productivity on site, boost the contractor's competitiveness, and then support a low carbon economy. So my current study, it's a PhD study, and I'm working with 2 building contractors. So BAM Ireland is one, and the other one is Kerry Building Contractors. They're a small SME contractor based here in Galway. And my project is funded by the EPA through the Cleaner Greener Production Programme. So to date, I've been on 11 case study sites between the 2 contractors. The first case study was with BAM. It was the construction of a primary and a secondary school in Dubishka here in Galway. Phase 2 of that works entailed the construction of 2 special needs units on the same site. Third case study was the construction of a cancer research facility in UCHG. And in UCHG as well, the construction of a multi-storey car park prior to the construction of an acute adult mental health unit. So the 2 case studies that are still ongoing is the acute adult mental health unit, and of course the case study we're talking about today, which is the HPB in NUIG. Then with Kerry Building Contractors, there were 5 other smaller case study sites. So the first one was the construction of a cystic fibrosis unit, again in UCHG. A new podiatry unit for Merlin Park Hospital. And then there were 3 very small case study sites. On the left there, that was a high dependency unit in Bon Secours Hospital. In the middle, a switch room on the grounds of UCHG. And on the right, the demolition of Block M in NUIG. So the reason I'm showing you all those case studies are what I base the KPIs or the key performance indicators on for the human biology building. So the case studies have ranged from 150,000 to just over 23 million. Have ranged in size from just 66 metres squared all the way up to 8,300 metres squared. I've carried out 474 site visits, and each site visit entails a resource efficiency audit. As I said, 11 sites, and the current study has been going on for the last 2.5 years. So why do we want to improve resource efficiency on the HPB site? Well, the 2 main things for the building contractor is there's going to be reduced costs, and there's also going to be improved environmental performance. So the key performance indicators that I mentioned, so the potential cost for the human biology building for energy, so your electricity and diesel use on site, that could be in the region of €108,000. Waste costs could be in the region of €87,000. So the energy and waste cost for that site could potentially be 22% of the contractor's profit. So if you can start reducing those costs, that's money that's going straight into the contractor's profit. And environmental performance, so the potential CO2 emissions are 536.85 tonnes. So how are we improving resource efficiency on the HPB site? So previous projects we focused solely on the construction phase, but with the HPB we decided to take that one step back further, as Mark was talking about, and we've also introduced it into the tendering process. So targets and tendering. So the targets are waste is not to exceed 15 metres cubed by volume per 100 metres squared, and that target is currently at just 0.66 metres cubed per 100 metres squared. We wanted to divert 75% of waste by weight from landfill, and that's currently at 96%. Within the architectural specifications, there was also various materials specified that had recycled content in them. Energy use not to exceed 100 kilowatt hours per metre squared, and we're currently at just 27.5 kilowatt hours per metre squared. And then water use not to exceed 0.2 metres cubed per metre squared, and we're currently at just 0.05 metres cubed per metre squared. So there's only 4 months of construction work left on site, and as you can see, we're well ahead of our targets. Then the tendering phase. So what we did was, we've got every subcontractor who tenders for work on site, they have to fill in what we call a resource efficiency plan. So it's basically just an expansion of a waste management plan. They have to outline how they're going to handle their waste on site, what skips they're going to use, how they're going to reduce their packaging, how they're going to manage their energy, and how they're going to manage their water use on site. So just run through a couple of practical examples of stuff that we've implemented over the last few months on site. So the first one was energy management in drying rooms. So on the left there you can see we installed a thermostat and also a door closer to obviously keep the heat within that building. So over the course of that project, that's going to save €418 and 1.9 tonnes of CO2. The lighting in the site accommodation as well. We've lots of porta cabins on site, and the lights are often left on during the day and also at night. So it's another huge energy use for us. And by installing occupancy sensors in these rooms, those lights are automatically switched off when they're not in use. So that's going to save €6,459 and 29.4 tonnes of CO2. Office equipment is another huge energy user on site. So by setting the office equipment to sleep during the day when it's not in use, and obviously switch it off at night time. So that's going to save just over €3,000 and 13.8 tonnes of CO2. Then nighttime energy use. On previous case studies this was a huge issue, and we found that on one of the case study sites 50% of our electricity usage was at night, even though no work was taking place on site at night. So on the left there, that's a situation that we're trying to avoid. All the lights left on at night, and on the right you can see a transformer box. So these transformer boxes, they still use 10% of their electrical output even when they're just plugged in. So our solution in the middle there, wire in a temporary switch that switches off the site lighting at night, switches off all the electricity on site at night, and that's going to save €10,249 and 47 tonnes of CO2. So for an investment cost of just €200. Your security lighting in your site compounds and also on your cranes. So installing photocells to ensure that that lighting is only in use during the hours of darkness. So that's going to save €2,268 and 10.3 tonnes of CO2. Moving on to waste then. So because we had such a confined site, we could only have 3 skips on site. So we picked timber, metal and a mixed waste skip. So timber is generally in the top 3 types of waste on site, and the metal will obviously generate revenue for the contractor as well. So by having the 3 skip policy, you'll reduce your waste management costs by 12%. So potentially for the HPB, that's going to be €10,430. Then skip void space. So this is something we're trying to avoid, incorrectly packed skip. So skip void space essentially means you're paying your waste management contractor to dispose of air. That's obviously something you don't want to do. So what we did on a previous case study, we took all of these materials out of that skip and we repacked the skip with the exact same materials and just eliminate the void space as much as possible. So by reducing void space on site, void space makes up 13.5% of your waste management costs. So for the HPB, if we can reduce our void space by 50%, we're going to save €5,867. Site hoarding, so that's generally only ever used for one project. It gets wet, it gets damaged, and it can't be reused. So what we did was we used a special board that came pre-treated to site, so hopefully that can be reused for more than one project. And on the right there you can see concrete Kelly blocks. So these Kelly blocks, they're the hoarding posts, and they can just be picked up at the end of the project, brought to the next site and reused over and over again. And now just on that project, that's going to save €3,819 and 9.25 tonnes of CO2. Then Mark spoke briefly about take-back schemes. So 2 of the take-back schemes that we've implemented is for pallets and timber cable drums. So all of these get returned to the suppliers who deliver them to site. And that's going to save 4.8% on waste management costs. So potentially for the HPB, that's €4,172. Packaging then is another huge problem on site. It's also in the top 3 of your waste on site. So that's something that we're trying to avoid, having lots and lots of packaging in your waste skip. So if you can set up take-back schemes again with your supplier for packaging, that's a good practice example there from a previous site. We got the mechanical contractor to keep all his packaging waste and then that was sent back to the supplier for recycling. So packaging makes up 7.5% of your waste management costs, especially towards the end of the project during the fit-out phase. So for the HPB, we're looking at potentially reducing our packaging costs by €6,519. So I've outlined just 10 initiatives that we've implemented on site. There are obviously a lot more initiatives that we've implemented, but these are the top 10. And from the 10 I've outlined, we're going to make savings of €46,708, and that's equal to 0.2% of the project value. And also to note that the investment cost for all these items was just €892. So the overall cost savings is equal to 24% of the total waste management and energy costs on site. So we're reducing those costs by 24%. And if BAM Ireland want to make an additional €46,708 in profit, we would have to complete another €1.5 million worth of work if working to a theoretical profit margin of say 3%. So to conclude, all the possible solutions or initiatives that I've listed, they're all low cost quick win options. So very low implementation costs, and you can start getting savings straight away the minute you implement it. Resource efficiency is easily achievable, and we've shown that, and cost savings can be made in many areas of energy usage and waste management, not just the ones I've outlined today. And then maximising the construction industry's energy efficiency and reducing our waste are both good options for reducing our greenhouse gas emissions. So I want to thank you for your time. We're going to take questions at the end, or alternatively you can use the contact details.
Okay, thanks, Ian. So I just want to summarise what we've been talking about over the last 45 minutes or whatever. Just to refer back to Ian's presentation, one of the reasons why we focused on the construction phase is there wasn't a lot of work done on that. So you might see a lot of work and studies done on low energy design. There isn't actually a lot of work done translating to the construction phase. And if you think of a construction phase, it's repeatable. Your site accommodation, welfare facilities and so on are going to be on every site. And a lot of the initiatives you see there actually would link to home energy behaviour, taking energy as an example. You know, it's looking at lighting, heating and so on. So it's quite easy to do. We're also very conscious when we're with the main contractors is they still have their cost, time, quality, health and safety, and there are their priorities, or their triangle of priorities. And resource efficiency can't really impact on those. So you're trying to, the one thing they all want is reduce costs. So if you can demonstrate by implementing initiatives that might reduce their environmental impact, which they're also very interested in, but if you can show them that they're reducing their costs, well, you're on to a winner straight away. So a lot of those benchmarks, as Jan said, have been developed over those number of case studies and actually related up. Just from our point of view, what we want to do is try to use a case study then to glue all of these things together. So when you're looking at industry best practice, and the key word there, I suppose, is reciprocal. You know, we're lucky enough that the main contractor or the design team, as Scott Tanner Walker, facilitates us and allows us in to their industry and their site and so on. So we want to be able to give something back to them. So what we've found is the things that they've looked at are these KPIs, the key performance indicators for the reporting, educational initiatives and linking that to their on-site CPD and company CPD as well. Looking at trying to capture the lessons learned from one project and spreading that out throughout the organisation, which is a key thing. Also, it's nice to pick up a few awards as well from a company point of view, so helping them to enter into awards like that, so that's a good advantage. From our point of view then, where the great translation is back into the curriculum for us, so that we can give students the most up-to-date things that are happening on the site. We can use the case study for site visits, we can invite speakers in and so on. So, you know, it gives a sort of a real life to the curriculum rather than making up a project that may not exist. And we're trying to evolve it then a bit more. So, as we've mentioned already, we've been working with Ban Carey, SIS on the previous project. We're also Rattigans on the greenhouse or the Garda station. Persons are helping us out with some projects as well, and RPS looking at our BIM related projects. So it's very important for us to keep all of those links, you know, alive at all times, so that if any job can come up, that we can be involved in it. And what we're looking at now is to build on what Jan has been doing and to look at how can we introduce training interventions. So what we're doing at the moment is doing a survey of site personnel. So site management will all want to do it, but what we want to get at is people, site personnel, the people working, the subcontractors, all of those. What do they feel? What are their attitudes to resource efficiency, and how would that inform how you would develop a CPD over a project time frame? So they would have the advantage of being on site doing their work, but also getting their CPD elements and their points ticked off, so we wouldn't have to bring them over here, say for example, for a day to do the CPD. So all of that is happening at the moment. We're also looking to extend it beyond the construction phase and look at the life cycle embodied energy analysis as well. And what we ultimately want, and we're trying to filter this back into, say, our own buildings and estates department here, is that the GMIT itself will be an exemplar client from a resource efficiency and also from a BIM point of view, with all the good practice, so that as a client you have the greatest influence. And so we're sort of doing it a bit retrospectively. We're learning a lot of valuable lessons from industry, and we're going to try and translate them into the client. I just want to take the opportunity to thank Paul and Brian especially for all their cooperation, and Paul Carey, who's outside there for Carey Developments. You know, they've given us great access to all the projects, and without the access of the main contractors and the architectural teams and so on, we wouldn't have any of this research. So we wouldn't be able to inform students, we wouldn't be able to build our research profile and so on. So I just wanted to make note of that. As Jan said there, I think we'll leave the questions till the end, because I know David is keen to come on and do his presentation. So thank you very much.
So thanks to our four speakers, Mark, Paul, Brian and Jan. I'd like to introduce you now to David Taylor. David has joined us from the UK this morning. David has over 25 years experience as a managing director, providing architectural design and contract management services across public and private sector. David is a chartered architectural technologist, a chartered building engineer, and since May of last year, David is the Vice President of the Chartered Association of Building Engineers. Just one thing to add, David has agreed to modify his presentation slightly to help us get a little bit back on track since the timing of this morning's session. So if you see any slides being skipped, that's David accommodating us, and all of the slides from the presentations will be available online afterwards, so you can go back and read over them again if you wish.
Thank you, everybody. Can you hear me all right? Good. There is a little bit of a push in the UK. I appreciate that the standards in the UK and the standards in Ireland, there is a bit of divide. Architecturally, we all work from the same hymn sheet. Legislative standards have changed considerably, and I work a hell of a lot in the UK with the Party Wall Act, and I don't know if a lot of you are familiar with the Party Wall Act. And I know it's not relevant a lot in Ireland, but believe you me, I think you'll find it's on its way. CABE have asked to, well, they're driving, CABE and the Construction Industry Council are the two main drivers in changing for compliance and best practice methods. It's been highlighted over many years, and we've seen it on TV programmes, standards of workmanship, both in design and on site. And it's a big push which they're currently looking to change. This is not meant to be a critique against all professionals. This is just a standard which or an issue which we're raising, which affects all. It's been brought out there by professionals, and we need to look at changing things. So, Wayne has already introduced me, but apart from that, I'm also a panel member at the Grand Design Show, so I do have a particular knowledge and know-how of Mr. McLeod, who is later in the presentation. So what is meant by design or build compliance and best practice? Well, design and build, it's a method to deliver a project in which the design and construction services create both formal and informal relationships. And I think we've covered that in some of the presentations which we've just heard earlier on. Compliance, it's the action of complying with industry laws, regulations and instructions, planning, building regulations, Party Wall Act, BS standards. Best practice, professionalism and procedures that are accepted as being correct. This maintains quality and legislative standards based on one's self-assessment and benchmarking. I think we all agree with that. The general focus of this presentation is primarily residential. It's not commercially aimed, it's not industrial. There are presentations which are being put together by Cave which highlights this on commercial projects such as the projects that you've been discussing this morning or earlier. So, architects, technologists, designers, building engineers and general builders, they're the backbone of the built society, responsible for addressing some of the biggest and extreme challenges facing our industry both now and in the future. I think we agree with that. But there's a comment there from Judge J.J. Bailey, a recent comment, which is from about August last year. Architects, technologists, designers and building engineers are concerned with all activities involved in the design, creation, assessment, construction and maintenance of the built environment. Developers and builders are concerned solely with ensuring the safe delivery of all projects. We agree with that? Yeah? Quote there from CABE. The main emphasis of the architect, technologist and building engineer roles is the technology of buildings through their specialisms, which focus on the building design and the managerial aspects of the project at hand. Kevin MacLeod's quote, they are experts at encouraging collaboration across a wide range of design and management skills. Their integrity, communication, knowledge and skills maintain designs that work for today and tomorrow. I've highlighted the word there, integrity, and I'll come on to it later into the slide. Experts? Do we consider ourselves experts? It's a big word, experts. I think we've moved on. I don't think personally we can call ourselves experts. Knowledgeable perhaps, but I think we've moved on. Cade quote, the building profession is defined by its knowledge, principles and experiences allow its members to take personal responsibility for making better than random judgments for their clients and end users in areas of uncertainty and risk. You touched on earlier about contractors, workability, performance gap. This is what we're on here. Kevin MacLeod's quote again, the main emphasis of the general builder is to use their integrity, that word again. Creativity and technical expertise to achieve a better building performance, which is cost effective in the construction and operation process, ensuring end users meet their needs in a cost effective and functional, inspiring way. Do we see inspiring work on the TV with cowboy builders and things like that? There's a lot of it happening out there. We are all committed to doing the following values in everything we do. Whether we're architects, engineers, surveyors, students that are studying, we're all committed to the same values. To be professional, ethical, respectful and accountable. To provide quality services to ensure end user satisfaction. To meet the needs of clients, statutory requirements and obligations, associated professional colleagues and all of the matters of compliance. Yeah, that's an interesting one. To engage with others and maintain project teamwork and balance. We all work together, we all network. To promote our own standards to others. To learn from our actions and share your understandings openly. Evaluate and reflect upon our performance and feedback the findings. How many times do we still put our hands up? I'm responsible for that error. You don't see much of it now. It's quick. That's your responsibility. You did that. So, our primary objective in all that we do is to provide informative and specified information and a safe project delivery that will benefit all in the chain. We all appear to be in a mad day-to-day rush, and we are all guilty of not giving ourselves the chance to reflect and consider whether we're doing what is right in our professional lives, and or to consider that when it goes wrong, who is a negligent party. Are we sometimes a little bit guilty of being a little bit too busy, and we're guilty of let that little bit go? You know that you've not completed it, but we'll let that one go. That will get through. Nobody will recognise that. It happens, and it's happening a lot. So this is a general route that most of us are familiar with not using a contract. The client sets out the brief, he's appointed his architect as the agent, concept plans are produced, they're agreed, planning permission, successful, we hope. Question mark there, we hope. Plans and specifications are provided. Back to the client, building control submitted, approved. Maybe some conditions attached, not always. So the builder is appointed, subcontractors appointed, work starts on site, but will the project collaboration improve the quality and minimum standards that we all expect on site? We spoke about sites, we've heard about the sites earlier on, and they've come to fruition, they've been good jobs, but has the work all been to a high standard quality finish? So what could possibly go wrong? So I'll come back to this one a little bit later into the presentation. But these projects that we're going to go through, I'll start you off very mild ones and I'll actually start you off with one of mine, which has just recently finished last year. And then I'll lead you through to more serious if we've got sufficient time. And that is what I'm conscious of that as I've started. So, this is one of my projects. Everything down here on this side, everything's all approved. Building specification, planning, structural engineers, building control in place, party wall awards in place, health and safety paperwork in place. Simple planning project, 2 properties. Not a lot can go wrong with that. 2 party wall awards in place. And I've highlighted these areas here where we've got 2 steel columns going in. So generally works have started. We've got 2 piers. These are the piers what we're concentrating on. Upper floor joists are deliberately spanning to the centre of the party wall so as not to increase load on this main wall. Same again, but it's highlighted on that side in yellow, where the beam is actually supported, or what's at risk. This was picked up on site by the building control during a random visit. So you can actually see the pier. And that's carrying a universal column, it's not carrying a universal beam. So the weight alone on there is absolutely tremendous. And it was installed by crane delivered to site. The complexity of getting that crane on site alone to put that in. But the pier was constructed in the wrong place. So what did the builders do? They turned the block round on its end to make it fit and put a concrete block in place on top. So they obviously tried to get around this, but this was picked up by building control during the random site visit. But what would have happened if that random site visit hadn't happened? That would have been covered up, gone away. We'd have put a warranty certificate on that and we'd have moved away from it. But all that what I highlighted in yellow there was all at risk of collapsing at some point. So what happened? We were alerted to the issue by building control. We visited the site and we put in safety measures immediately. We called in the structural engineer and the new pier was constructed inadequately. The engineer has left site and that's what they constructed, another thin pier. Nobody around to see the work, we'll put that pier in place and we'll cover it up. So luckily it was just by accident, the engineer had gone back to site again, instructed that to happen. Subcontractors removed from site. That is now a legal issue which is going through court. So, and these next projects will show you my intervention where the legal involvement on this, where they've either got the solicitors involved, I've had to get in court injunctions on these jobs, and or they're being represented in court now. But we're only talking about workmanship, both in design and build, in the last 3 years. We're not talking 20 years ago, we're talking 3 years ago. This is a standard of what we are now getting, and we need to stop it. And this is on a small scale. So this one, 2013, infill project to a terrace property. It's got full planning consents obtained and approved, works under a building notice. We're all familiar with the building notice, yes? At the same term in Ireland, or it is in the UK. Local authority, no party wall notices served. No agreement with regards to drainage discharge, no building contract in place. The builder was chosen as the cheapest quote. How often do we hear that? I was appointed by one of the property owners to because of the damage which occurred to their property through a beam which pierced their wall. So I went to site, and this is what I saw when I went to site. And as you can see, they're going through the numbers. We've got different types of block work, 3 different types of block work there, just to make up that wall. It's all laid flat. We've got joints perpendicular to each other. How often do we see standing work like that? We've got a beam there that's running into the wall, which is number 8, and that connects with the beam bottom number 6, where the timbers are returning into the beam. But the timbers are all split, but who did they have tirelessly on site, cutting out a groove to sit timbers into a steel beam like that? It doesn't happen. So all those timbers were all split. What a waste of time. Number 5, you can see the height of the adjoining owner's wall plate. On this one, the wall plate there, number 9. It's a block and a half lower. It's a standard of work, abysmal. But back to that, number 8, the beam number 8 is actually penetrating the walls of the adjoining owners. Goes further, this. Up there. This is the lintel over this window. And it's actually 3 millimetres sitting on the face brickwork there. It's not even sitting on the blockwork inside. And again, the same thing here. We've got a timber which is actually sitting in the face brickwork, blockwork. No padstone on here, and again, we've got water joint continuous all the way down, 2 beam supports. So this was an horrendous job. And what happened next? I got asked to get involved by the adjoining owners due to private wall damages. The damages were so severe, I obtained a court injunction to stop further work. Has anybody in the room done a court injunction? Have you had to go and do a court injunction? Yeah? Not nice, is it? So we investigate the work carried out as part of the condition schedule. So there was no condition schedule done on either one of the properties neither as part of the remit to do this work. So we alert the building owner and we call in a consulting structural engineer. The building owner directly communicates with the building control. The building control confirmed no inspections since the excavations. So we're at that point, what we've seen there, the building control have not seen anything since they've done the excavations. So the building control visit the site and condemn the works. Planning enforcement visit the site following building control feedback. There is, in the UK, I'm not sure about in Ireland, there is a reason why on terraced houses there is a gap. And that gap is usually for water services or drainage services that run through. You're not allowed to build over that. I don't know whether that's like in Ireland, but this wasn't picked up anyway. So there was no application made to the water board. The client discusses with his designer, and his designer refuses to get involved. So yes, he had a designer on the job, but the designer refused to get involved. Amazing. I was asked to take over the project. I declined. The building control visit and advise on making the site secure, no further works. The building owner proceeds with legal claims against the builder. The building owner proceeds with negligence claims against the designer. The designer has no PI and worked for full-time in the REBA registered practice. Risk. Water Authority refused to build over and the building work is then demolished. Today, the client's cost in excess of £90,000 and the case is ongoing. So this is just giving you a taste of things. 2013, again, 3 years ago, 2.5 years ago, grade 2 listed building. Full planning consents obtained, conversion 5 flats. Conservation consents not yet issued but agreed in principle. Local authority building control full application, but full plan details not approved. I got called again by the adjoining owners to look at the party wall matters, damage to either sides. This is a listed building, a grade 2 listed building. This is what I found when I went in it, and this was like a war zone. These are builders providing general building services. In the UK, they can go one day and pick an hammer up, and the next day they can go out and build themselves a building. That was a grade 2 listed building, stripped of all its assets. And on slide 3, this one here, this is me laying down on that floor up there to get the underside of the ridge. What happened next? Asked to get involved by the adjoining owners due to party damages. Request builders to stop further work until the damage extent. Party wall surveyor is appointed to act for the building owner. We investigate the work carried out as part of a condition schedule along with the building owner's surveyor. So why wasn't the condition schedule carried out when plans were prepared? Unbelievable. So both surveyors call in a consultant structural engineer, building owner surveyor asked for immediate party wall remedial works to be carried out. We decline the challenges request until an appropriate wall is in place. Calling the building control calling the planning department, conservation department. And as a matter of course, the police are already involved in it. They have to be, it's a listed building. It's a criminal offence. The building owner informs they were given the go-ahead by the designer to commence the work. The designer for the building owner is then interviewed on the police caution. The building has been totally stripped out of its features and completely ticked. So the building owner is then interviewed under caution. He demands he is innocent, as he would. All work is stopped and conservation is supporting to salvage the building. The building owner receives a £5,000 fine from the local authority and is further prosecuted. The building owner is fined in court £30,000 in order to put the character back. Negligence claims was awarded against the designer, and the designer had verbally agreed to commence work at the site meeting. So, although no paperwork, no contracts, nothing in place, the designer has said, yes, you can go ahead with that. Clients are astute enough to hold him to that. His professional indemnity was £250,000, restoring works were in excess of £200,000. He then resues the designer because he's termed himself an architect. How many times have people referred to it as an architect? I'm a chartered architectural technologist, but people often say, oh, you're my architect. Not an architect, but how many times have we come up against that? I'm being told about time here, so I'm going to go through this and take me to really to the end, because I need to highlight the changes with what they're looking at doing. Just back to this one slightly. Everybody involved in this job, the architect, the building control, the building contractor, the ground worker, are all being sued. They're all being sued. The architect never advised the client of the party wall matters. The building control gave an instruction which is now being investigated. The building contractors carried out the work. There was no insurance in place, so they are now being pursued through the court. What about this one? I don't know if any of you saw this. This was on Channel 5 last week. Did any of you see it? Simple one. Ground floor flat, first floor flat. People in the ground floor flat, young couple, wanted to do the basement work. They were the leaseholders of this property. They'd done everything right. Planning consent's fully approved, building regulations fully approved, party wall rules in place. And as you can see there, they've started excavating for the basement, and the walls come away to the extent that it's now gone. So it was exposed by Cascade News, Daily Mail in 2012, and it was shown on Channel 5 on the 29th of February. So you can actually watch it again on catch-up. High Court judgment was made in September 25, and the builder was fined £287,000. Social media involvement on that is quite interesting. But the judge's quote, the builder is purely to blame along with the building industry, which even in the area of the sector remains shockingly under-regulated. And this is the push from CABE and CIC, the Construction Industry Council. This is where they're now going. This word integrity, I've put SEC up there because it's not just in our industry. We've seen it in the football side there. But real integrity is doing the right thing. And the person's test of integrity is his or her refusal to do or say anything that will be damaging to others and themselves. It is following one's moral and ethical conviction and doing the right thing in all circumstances, even if nobody's watching it, and being true and doing nothing that demeans or dishonours yourself or others. It's a big word. Kevin McLeod. This is Kevin Blunden, Chief Exec from CABE. As part of their push, this is on their agenda to discuss at a few events throughout this year. But this is what Kevin was had to say. Providing and maintaining the quality of a building that can function at the highest level are now collective major issues which need to be addressed, and achieving this will be challenging. All parties, professionals and builders alike involved in the construction process from conception to completion and beyond have a duty of care and responsibility to building end users to not only meet minimum recognised standards but to provide high quality projects of design and to strive for building excellence throughout that process. Construction or building performance failure is not an option. Build quality is a collective responsibility. Sam Orwinkle, I'll put this up there, who's from CIAT, he's now discussing this very topic this week at the EcoBuild. This is on a panel debate, which is all been discussed at the EcoBuild, so I won't read that through, but it's basically very much like Kevin Blunden. What's happening? These documents. So what can be done professionally? So there is a document in place now called Collaboration for Change. I don't know if any of you are aware of it or seen it, but professionally they're looking to integrate this. So it's one to look for, it's one to read, it's one to grab, because this change is going to happen. Closing the Performance Gap is another document which is now ongoing. That's in its draft format. An interesting read. And the IES, International Ethics Standards, they're also looking into this as well. Three good documents that are all worth a read. So what can be done to improve buildability? In the UK, third-party or self-certification is now being discussed. So as an architectural technologist, as a chartered building engineer, as a chartered surveyor, minimum size extension works, ground floor, first floor extension out 6 metres by 4 metres, just an average. You will be able to sign it off. You will not need building control on that project. This is where it's going. So you, as a designer, would be 110% completely responsible for that project. That's where that's going. Education and training, closing the performance gap. It's interesting how you guys used the word earlier on, the performance gap. How? I'm not sure. Accreditation, again, I'm not sure how that one's going to work, but in Europe they have the licensed building register. Germany, France, Belgium, Ireland, there is building registers, but in France, they have it now where the builder is responsible for the project for the next 10 years. So it's the builder that's actually issuing the warranty for it. Increased use of contracts, I'm not sure. Tighter insurance agreements could work. Again, I'm not sure. Would a clerk of works be better employed? I don't know. Do we have clerk of works in Ireland? So would they be better employed? Small scale projects? I don't know. Building control. What does the future of? Can it be improved? I'm not sure. We're now looking at planning coming in the same way as building control. So you are going to have an individual planning people. And that then is going to go back to the local authorities. So it's all changing. So I've had to fly through that because of time. There's so much more in it. So please, if you get a chance, go to it.
Thank you, David. And just a reminder that those slides will be made available later on. And thank you, David, for modifying appropriately for us to accommodate us very well there. Thank you. So we do have time in the schedule for a few questions for any of the four guys who presented at the start, or for David. And anybody would like to start.
Just getting back to the radiology building. I just was wondering there, when I was watching this project, in regards to the strategies, environmental strategies, in regards to natural ventilation. I mean, these all have a connection to keeping down costs in the long run.
Sure.
But in regards to water management systems, in regards to drainage systems, again having impact on, you know, the overall cost of new systems to improve the lifespan. And, you know, generally just Julian's looking at, you know, where is the, you know, the ecosystem services should have putting into this lovely name for the building, what it is. I'm just wondering, I'm sure there are strategies there. I'm sure you've got really strong strategies for the energy conservation as a PV law, the blame that goes with that. But there wasn't much said about that. I mean, are they incorporated into it?
Yeah, I suppose I need a whole afternoon.
Sorry.
So, but our own company, we have our own ISO 14001. That's an environmental standard that we work to. So that unlike some of our competitors, that doesn't just apply to recycling and drawing waste in the office, but it applies to our design at every stage on the way. So at each of those, like the RIBA design stages, at each of those stages, we would have an environmental review, which has in electronic format is a questionnaire and a checklist and a series of supporting documents for the designer to check. So we try and aim for best practice anyway, regardless of whether there's a client brief for BREEAM Excellent or whatever. In this case, the project was explored as potentially a BREEAM Excellent project. The client declined in the end to go with that for a variety of mainly, not exactly cost reasons, but mainly time reasons at the time. And nonetheless, though, we did refer to that as a kind of a standard in our design efforts. It is extremely difficult to do a fully naturally ventilated science building, and the form of the building has allowed us the opportunity to naturally ventilate the office areas and some of the teaching rooms. And in the laboratory areas and the specialist rooms, mainly it's about, there is some natural ventilation, but mainly it's about heat recovery. A lot of the air coming from some of those processes is contaminated air through fume hoods and through extract from natural areas and different things. So it's not possible to recycle it exactly, but we can recover it from. So there's a variety of things. We've designed into the building some systems which are not all invoked from day one. There's rainwater harvesting provision that's not invoked, but the infrastructure is there. There's a photovoltaic array as well. And in addition to that, we would develop a green specification. So the specifier will have assessed in a spreadsheet the greenness of each of the materials that we will use in comparison with others. We keep a sort of an in-house, behind-the-scenes record of that. Especially a project like this, it goes on a long time. Over time, the design has been shelved and stopped and started. So standards change, and some manufacturers have improved in raw cement over the time of the project. A good example would be things like flooring, vinyl versus rubber, for instance. We would have had a lot of rubber flooring, which was regarded as extremely environmentally friendly 10 years ago when we started this design, but over the meantime, the vinyl manufacturers have improved their recycling, improved their processes to the extent that it's not quite the same. So, yeah, there would be, if I had a little bit more time, we could do some of that, but there are strategies in place at all those levels. Just to finish up, what I didn't say there was from the architect's point of view, and what I tried to concentrate on this, is the big picture thing, you know? And sometimes we have to shoot ourselves in the foot and question the client, do you really need this building at all? The most sustainable one is the one you don't build at all. That's the first, we do ask that question. Secondly, looking at the choosing the right site, you know, an intensely developed brownfield site in the middle of the campus with services already there, exploit those expenditures, exploit that energy that's already embedded in the site. And then, in addition to that, this science building we've attempted to build with a 3.6 metre floor-to-floor area design. Isn't thanking me for that, but that involves very closely coordinated services and a flat slab, which isn't always conducive to low cost and to precasting, but they managed to do it. Which means that you take out a whole panel of building on every floor all the way around 400 millimeters deep. It really outranks your rainwater harvesting and a lot of these other things over the lifetime of the building. The energy to heat that, maintain it, the embedded energy in it, those are the
question a second ago, I think.
Yeah, I'm just interested in regards to resource efficiency. Where would you see that within an organisation? Do you see that as a full-time role or something? Would you see that as part of the team, quality manager or the environmental manager?
Well, say, I'm not an employee of BAM, so I suppose it's
Yeah.
kind of unique in that sense, but I would work very closely with the environmental health safety officer on site. But again, it's not really part of our role either. You're kind of relying on a lot of goodwill. I think for an organisation like BAM, they would definitely have one person employed, but it would be across, the whole company, and they would have to visit each site, on a bi-weekly basis or a monthly basis or whatever. I definitely think for a large organisation, there is scope to have someone employed in that role. But having one person solely on site doing that, probably not. But to be fair to the guys, everyone kind of takes their own role and everyone's involved in it, what I'm trying to do. So.
Yeah.
We have time for maybe one more question if anybody would like to ask anything.
I'm actually in, this is for David. Is there a register, a mandatory register in the UK for contractors, as in here, I don't know, maybe, I know there is the CIF have a register. I don't think it's mandatory in that scenario. Anybody is set up as a contractor in the morning, and what's happening is people who are trying to enforce regulations, at the end of the day, I don't think the problem is with the enforcers, sometimes it's with the end, it's the people who are actually, you have to actually talk to on site and say, no, you're not doing that like you should. And that's where I find it a difficulty. So, although I think there's supposed to be the CIFRA register here, it hasn't come in as on a mandatory basis. And I think until we do that here, we're going to be stuck with a big problem, in my opinion. And in the UK, have you got the same issues?
It's a continuing problem throughout. And I think that the discussions that are ongoing now with government in the UK, CRC Council, CABE, and one or two of the other topics, I think we were already involved in it as well. It is a big push. The only thing that I can say that is probably something that will be coming out later this year, but a register seems to be a favourable approach, similar to what they have in Germany. The one that is changed now in France seems to throw an awful lot of emphasis onto the contract in terms of responsibility. In terms of qualifications for builders, I don't know if there is. I don't know if there would be some kind of qualification for builders. I'm not sure.
Well, it's just a case of, a chap says who he is and what he is, as a painter, whatever he is, and you find out that,
But this is why they say about insurance.
the apprenticeships. It might help to create apprenticeships so we move them and we start them up in that sense.
But the answer, I don't know. I really don't know. Jury's out on it, we've got to wait and see what happens.
Okay, thank you very much for the questions and for the answers. Just final thanks to our four speakers, Mark, Brian, Paul, Jan and David, and thank you for attending the event.